Hello, fellow laser geeks, and welcome. I'm going to talk about what drives the laser beam penetration. Power versus penetration analogy. Take the same power source. In this case, we start with similar setup in life. Imagine a garden hose at 100 psi with a 1-inch opening. It sprays water, but the stream spreads out and loses reach. Put a 1/4 inch nozzle on the same hose. The jet shoots farther and hits harder because the same pressure is squeezed into a smaller exit. Here is the math in words. The diameter change is 4:1. Area scales with diameter squared. 4 squared equals 16. That means the nozzle concentrates delivery into 1/16 the area. Intensity per unit area goes up by a factor of 16. Now map this to photons. Keep the same laser power, but change the beam diameter. Use 100 microns versus 25 microns. That is the same 4:1 diameter change. Area again scales with diameter squared. 4 squared equals 16. So the 25 micron spot delivers about 16 times the energy per unit area compared to the 100 micron spot. Same source, different focus. The business end sets the outcome. A 25 micron beam will go deeper than a 100 micron beam in this setup. That happens because the energy per unit area is much higher. But the depth does not increase 16 times. Material physics reduces the scaling. Start with absorption and reflectivity. Only part of the beam couples into the metal. Highly reflective surfaces return energy. Oxides or coatings can increase absorption. Add thermal conductivity. Metals like copper and aluminum pull heat away quickly. That lowers the local temperature rise and limits depth. Consider heat capacity, density, and phase change. You must apply energy to heat the metal, to reach the melting point, and to cross the latent heat barrier. Okay, let's get back to laser welding in real time. In this exercise, I'll show the versatility of laser welding. I have a stainless steel box, and on one side, I'll weld a galvanized coupling to it. On the other side, I'll weld a copper coupling, both using stainless steel filler metal. But before we go there, I will plug in how did I made the box, using the combination of wire feeder and fusion welding. This box will serve as a water to electricity transfer unit. I'll feed 1 inch of high voltage into a 1-inch water line, creating an advanced hand cleaning solution designed for extremely dirty hands. I know the audio isn't great. I'm recording on my phone without an external mic. And trust me, you don't want to hear me swearing every 15 seconds. Plus, I'm mumbling so much I can't even understand myself. You might ask why I'm doing it this way. Well, that's a fair question. Honestly, I don't have any grand plan besides the electricity to water transfer idea. I'm just building and experimenting, and I hope it's not too boring to watch.
I didn't weld it done. Someone was thinking about that. Oh, stupid guy, maybe he welded down on the table. He didn't.
Between error code 028 popping up, my own personal screw-ups, and the fact that I'm basically swearing on loop, trust me, you're not missing much.
The unit is set so low. Even if I wanted to, I can't. Fucking 28.
When the unit is set for wire feed welding, the power is 540 watts. When it is set for fusion welding, the power is 300 watts. The wire feed rate is 65 when in use. The rest is too long. Also, it would not apply to your laser welder, because my unit is not a factory unit anymore. Sometimes I wish I could crack the firmware and turn this thing into a space-grade laser welder, but the manufacturer has it locked down. Maybe one day I'll swap out the entire main board, grab one from Max Photonics or another Chinese board and firmware maker like Friendus, Bochu, or Ruida. If it hooks up cleanly with this gun, great. If not, I'll just run it with a Chinese gun instead.
Should I crank? No, still I got nothing. That's not good enough. Woohoo! That's interesting.
The plastic caught fire right there in the video, but I just kept going. I didn't jack around with it. I didn't stop to fuss. I pushed through the burn and finished the weld. That's the reality of shop floor experiments. Sometimes the material fights back, but you keep the gun steady and see what comes out. This clip is about 4 years old. The welder had just come back from repairs, and I was screwing around with it. Ended up welding 2 pieces of HDPE plastic into a T-joint. Not exactly what the manufacturer had in mind, but it worked. Sometimes the best tests aren't planned, they're just what happens when you've got a gun back in your hands and want to see what it can do.
I don't know, somehow I forget to turn this thing on. So anyway, I have this little thing, put it inside, underneath the tab. Get corner tabs. When I turn it so I can adjust if I need it, but it shouldn't be any high difference because everything is the same. I move this away, but also not necessarily because my unit is on 300-ish. It's not going to burn through. Just to avoid it. Now I have to find the port. Because I have 4. Oh, here. Okay. So, something like this. Okay. Now I'm gonna
Welding satellites with a shop floor box like this, already happening. They done with lesser rigs. The real leap will be building spacecraft in orbit and doing it with no shielding gas. Imagine orbital welds, clean joints, and no purge setups, and no error code 028. Just lock the board, fire the gun, and space fabrication becomes everyday reality.
Just for shits and giggles. You don't even need force anyway. The reason it's better is to do it a little bit lower, but I think it's more than low because it's easier to fill the gap. So I left 1, 2. I'm gonna load it. Big draw, wire off, 380s. We don't need wire. Okay. Let's see what is going to say.
That banana destroyer clip is from the same day I welded HDPE plastic. Back then, laser welders were still treated like a mythic fairy tale. Nobody believed they belonged in a shop. But in my shop, we switched from TIG aluminum to laser. Production sped up, less grinding, more welding. At the demo, I knew I had to rethink jigging, and I said it would be worth it. It was. I'm going to sand, clean, all welds, all edges, not because it looks bad, but because that's the way I like it. I left out one edge. If you're buying a laser welder mostly for sheet metal fabrication, don't waste money chasing high-end small beam units. A 25-micron spot isn't forgiving on thin metal. It's better suited for thicker sections. Sure, it will weld, but it can also puncture lots of invisible holes into your workpiece. And if that part has to be liquid tight, you'll be scratching your head. For thin sheet, 100-micron delivery is more than enough, and you don't need more than 1,500 watts either. Here's a pure example, my Coke can close-up picture. It's more like stitching than a real weld. It will hold compared to the base material, but nothing else. Found a few holes. I lost track when I was welding the edges, so I correct it using TIG wire. This box will serve as a water-to-electricity transfer unit. I'll feed 1 inch of high voltage into a 1-inch water line. This box has to hold water pressure, but at the same time it has to release the amperage. It's not just a container, it's a transfer point. One side is mechanical load, the other side is electrical discharge. That's the balance. Keep the pressure locked in, let the current flow out.
cool down. I should have brought this thing closer.
This box will ultimately clean dirty hands forever. By feeding high voltage into a water line, it becomes the ultimate hand cleaning solution. It is not about plumbing or electricity. It is about showing how far versatility can stretch and how laser welding lets us build anything into one chassis. The point is simple. Versatility demonstrated. Hands cleaned forever, at least in the story. I hope this video gave you a clear view of what's driving ultimate penetration in laser welding. If you didn't know, no surprise, it's quantum physics. And not many everyday people are reading books on that topic. Thanks for watching. If you liked it, please give it a thumbs up and subscribe for more.